All right, thank you, David. Our last speaker this morning is very timely given the World Cup. So Sam Lawrence is with FSB Technology. Sam has 16 years of experience within the remote gaming industry and is the CTO and co-founder of FSB. FSB provides turnkey solutions for over a dozen sports betting operators across Europe, Africa, and Asia, including managing betting markets across 23 sports and 75,000 and more live events annually. Please join me in welcoming Sam to the stage, please.
Didn't know I was in the morning. All this time I was.
Great, good morning. So, how do I go forward? I'd like to talk about sports betting and about, I guess, what I've learned from sports betting and about how we've used in-memory computing to help deliver sports betting online. It's an industry that's really changed quickly over the last few years, so a real explosion. So I think as a sort of case study, hopefully it's interesting and relevant. First of all, a little bit about me. I'm the CTO. I co-founded FSB 11 years ago now. Before that, I was at another gaming company, originally Game Account, now GAN. So we learned a lot of lessons and then split off, set up again, and tried to do things better and differently. Made some of the same mistakes, but hopefully I think learned. I started computing. I was born in 1972, so the first computer I had was a Z81. I don't know whether anyone else remembers them, but it had 1K of RAM and it had a 8-bit CPU. And I didn't have a tape machine, so it was all in memory, I guess, as well, because if you wanted to back anything up, you had to press record on the tape machine and it would record. I guess most of the storage was in magazines and books. You would type things in, and actually 1K doesn't take that long to type, so it was early days. I guess when we started FSB, I was very hands-on. I'm less hands-on now, but I think I'm kind of close enough, I hope, to see what's going on. And this is a picture of me from 1985. Disclaimer, my uncle was the editor of this magazine, so he asked me to come and be on the cover when I was 13, that would be. So today, I guess three bits, and then just wrapping up the end, a bit about sports betting, a bit about how it works, what it is, and then a bit about FSB, what we've done, how we started off and how we've changed it and adapted it along the way. And then finally, just some sort of personal takes on the in-memory part. Sports betting. So sports betting is a mixture of, I guess it's a lot of maths. It's got the finance part because you're moving money around. It's all about sport, and it's got there's a lot of technology doing it online. I guess the first early days, people would just put money into a hat, and you'd watch a match or you'd watch a horse race, and you'd spit it out, giving the money to the winner. That's more like the sort of tote or parimutuel betting, which is still popular in France, and I think it's the norm for American, US racing as well. In the early 20th century, there was a big explosion, and they made these huge mechanical machines to try and keep track of how the money was, how much money was on different horses. This picture here is from a machine in New Zealand, 1913, and it's kind of the size of a warehouse. I mean, it's like a just enormous machine with these elliptic gears that they use for keeping track and adding up. I mean, it just as a sort of parallel, it's just amazing to see sometimes how kind of technology kind of grows and grows within the boundaries that it has set. I mean, this was, machines that just were built bigger and bigger and bigger. Fixed odds is where you offer returns based on how likely or unlikely you think something is going to happen. So in a horse race, you're going to get less returns on the horse which is known to be the fastest or the healthiest or has a better history. Fixed odds gets around a lot of these liquidity problems that you might find with tote betting, because you can bet on anything. You don't have to have all the money in. You don't have to match up with other people who are betting at the same time. I'll talk a little bit more about that in a moment. Online, I mean, it's gathering data, I think, which has really transformed it. I mean, there's been a shift from people betting in person, retail, but also the amount and the volume of data that's fed into the pricing has meant that there's far more opportunities to bet, to move money around. And the more that you can move money about, then from a bookmaker's point of view, the more opportunity for turning that into margin, for turning that into revenue. This fixed odds part, which is really about how can you calculate the probability that something's going to happen. If you can calculate that really well, then you're going to get better margin. A little bit of maths on the right-hand side here. This is calculating, I guess, the probability of goals in a football match. If you took years of data and you counted the number of goals that you had on average, you'd find it might be a little less than 3. You can use like a lot of these distribution, like Poisson distribution here, for calculating the probability of how many goals there would be in a game. And you can use that probability then to turn into odds as a bookmaker. I guess there's still a lot of maths. I mean, I think, the data's transformed it, the computing's transformed it, but underneath, it's still a lot of maths, and it's a lot of the same maths that's been around for a long time. So that part isn't a huge change. I guess the thing that really has changed is the volume of data, the frequency of data, and the depth and the detail of data that is available now. Other challenges, there's a lot of volatility. Saturday afternoon is when all the football across Europe is played. So that's a really huge peak in terms of bets coming in and data coming in. Regulation, there's a lot of change country to country. Here in the UK, it's changing all the time. The UK Gambling Commission are taking a lot of best practice from other areas, from finance, from like the FCA, the CMA, about how you can advertise, about how you can, spotting things like spotting potential money laundering. There's a lot of new regulation in terms of maintaining and building a platform. There's a lot of change that generates all the time. As an industry, always looking for new ways of actually trying to offer product. So there's a lot of things like cash out, you hear a lot about here. That's where you can take a bet and actually take your money back out again. So you're then having to calculate the probabilities of an event, the likelihood of something happening through a game at the same time, not just offering pre-match odds. So again, more computational complexity there. And all the competition, actually just keeping up. It's a with all this opportunity, there's been a real, I guess, bit of you call it a gold rush. A lot of people have, piled in to offer sports betting. So it's quite a crowded space. It's a very busy space, but it's, with other opportunities opening up, like most recently, I guess, the US law changes. There's still a lot of opportunity here. Picture on the right-hand side, I think I got a bit random with some of the pictures I was trying to choose because I'm never quite sure what to include to illustrate some of these things, but I thought this was quite an interesting picture. It's basically a computer and it's a hydraulic gear. Anyway. Why is this relevant? Maybe the hydraulic gear is less relevant, but it is the World Cup. And I think just as an industry, the change we've gone through, the rapid change, and how we've tried to solve and how we've taken advantage of data, hopefully that's relevant. So FSB, the company I co-founded, we provide sports betting as a service. We are an operator and a technology provider. I guess being an operator, we see a lot of the problems. We understand a lot of the issues that people would have in running it. We run lots of different sites, versions of the site for different countries. I guess if you came to FSB and you wanted a sports betting site, we could build it, we could brand it. We don't do the marketing, so the partners come and it's their brand. We skin it with their colors, their site. We run it. When we first set up as a tech company, we were out raising money, and we wanted to get something built and actually prove that we could do something. It was a very simple architecture. Back 10, 11 years ago, I think in the Java world, it was a lot of sort of EJB3, it was Spring, it was AOP. That was the kind of time. That was what's going on. So it was just a relational database and a Java application server. Lots of JMS, all the data coming in and moving around. We still use a lot of JMS. And we built it at the time using Glassfish, so that was the Sun, original Sun Java application server reference edition. Moving forward, as we started to, I guess, get a bit more volume going through, in the early days we were doing more around fantasy sports, and I guess then we saw that this sort of shift towards sports betting was the thing that was going to be generating more revenue. So it was really around 2013, 14 that we focused much more on the sports betting part. We get a lot of volume of requests coming in for that data from all the different clients. If you're looking at a website and you're looking at these different odds, you're lots and lots of clients to grab this data, also push it back again. So the caching part, I guess, was our kind of route in towards this in-memory bit of the computing. We started off with memcached, which is just a very simple key pair cache. It worked fine for a bit, but it was, pretty soon we found limitations with it because we wanted to do more complex structures, have more complex structures in that cache, and to be able to query it in more complex ways. We also added Mongo. We have a lot of data which is data from sports. I guess when that data arrives, it is arriving as XML or JSON data generally. When you have a sporting event and something happens, a lot of that data changes all at the same time. So an object-based data store works really well for those kind of updates. And I guess the updates which are less about keeping transactional integrity, which is where Postgres has worked well. Going forward, and this is pretty much where we are now, we put grid gain in place for the cache, so we can have much more complex structures and we can query those structures. For instance, give me all the events which are in play for a certain league, or give me all the certain types of markets for one sport. You can take all that data from the cache and pull it together and give it back to the end user. We also use it for a lot of the liability calculations when bets come in, because you're managing risk. If you take too many bets on one side of the game, then you're going to put yourself in a position where you've got a really big liability. So you're trying to incorporate that information into changing these prices and these odds that you're offering at the same time. So that's looking at all the bets that you've got in the system which are not settled, and then doing fast calculations based on what might happen if a certain outcome does happen. So this sort of, I guess, fast MapReduce type calculation that you can do on that data which is in the grid. We also use grid gain for locks, I guess, where you've got processing and you're trying to avoid some of these concurrency problems. It's very good just for having a simple distributed lock. So just a very simple pattern of, lock, release with some code in the middle. You can do that very nicely over a grid. We've still got Postgres as this master of all the data. I guess it's probably partly my background coming from relational databases. I'm not quite ready to get rid of that part. I think at some point we probably will sort of shift some of that transactional integrity more in memory. At the moment, Postgres is this kind of final master arbiter of all the data, and actually seeing how much of the incoming data, how much of the processing we have to spend. I mean, probably 80% of it is trying to clean up this data, is actually trying to marry up slight oddities, and I guess in that way I'm much more comfortable having something at the end which is really just ensuring that the data is well structured and can be queried afterwards and used without having anomalies. We run lots of different instances of the platform, and we can scale by adding additional virtual machines in the environment we're in. So where we have those big peaks on Saturdays, we can just fire up more VMs, and grid gain scales, the whole middle tier with the application scales as well. Postgres doesn't scale in that same way, and I guess that's another reason why we might want to shift some more of that processing back into being in memory again. Where next? Yeah, I didn't know what to use for a photo here, so this is actually an avocado with an Eat Later sticker. We've got a platform now which is working, it's stable. I think this is partly the background of coming from a small business and trying to kind of invent and, trying to see what an opportunity is in the market and, being this sort of entrepreneurial side of how can you, turn that opportunity into revenue. So I think this is partly my mindset, but I think it's, just in terms of being a company which is small and looking to adapt and survive, you have to keep inventing. We're running quite a few different sites for different customers, so a lot of our backlog is driven by customers, and they ask for the things that a lot of other competitors have. Sometimes they come out with crazy ideas, and a lot of the time they ask for things which are just don't seem useful, but that's our backlog. I think as we get customers which are bigger, there's going to be more sort of enterprise needs. I mean, things like disaster recovery. We've got DR structures in place, but this is always a sort of, this yardstick of people who would want, redundancy across different data centers. We're not doing that. At some point, someone's going to come and say, what happens if, and it's going to be a scenario that we're not covering yet. So I can see that that's where we'll want to, start to scale out even, bigger levels of redundancy there. Some sort of personal thoughts on in-memory computing, I guess, since we're here. This meme, Abe talked a lot about the future, and I don't know. I was wondering, I got to the fourth, this sort of woke brain meme. I didn't hear any talk of robot butlers, but we've been promised robot butlers since about the 1950s, so I, for one, would love to have my breakfast brought in the morning by a robot. I think that'd be pretty cool. I think this in-memory computing, it's gone from, certainly the way that we adopted it, we started off, we were caching data. We were then doing much more processing in the grid with the data. This HTAP or HOPE, where all the analytics and processing of the data is in some container together, seems to be, the sort of the modern end. I'm really looking forward to hearing what, some of the talks over these next 2 days to see what people are doing with in-memory computing and where it might be going next. I guess the real drivers have been I mean, it's usually about performance. I mean, just having faster processing of data and actually being able to handle bigger volumes of data where technology has changed to actually be able to capture more data and, you know, where I guess things like machine learning and AI have given more tools for being able to process big chunks of data at the same time. I'm interested in this relationship with storage as well. I guess in memory computing is kind of defined as being without storage, but at the same time, storage has got faster too. So that's another area that I'm interested to see. I know last year in Amsterdam there were some talks about this sort of memory and having persistence in memory as well, and some of the complexities there. This is another area which I'm curious to hear more about. I guess this, in terms of what questions did I ask when looking around, when we were, you know, adopting new technology. I mean, I think some of this seems very obvious, but it's not just how fast or, you know, how much processing. It's also about the support and about the community and about the developer tools and about, you know, being able to create and maintain code which is doing what you want it to do. This graph on the right is the number of bets that we have taken as a platform. So you can see we've had a really big rate of increase over the last few years. The column on the right is 2018 so far. So I think we're not gonna keep going up exponentially, but it's gonna still be another big bar. The last final point I wanted to make was just about developers. Just in memory computing, a lot of it is quite hard, and I know just having a team actually trying to, you know, get developers who are able to work and understand how in memory computing works. I think you need developers at a certain level who can do this kind of computing, and I'd really like to see this brought back to just to see a lot of this knowledge about in-memory computing, you know, brought back to be more kind of commonplace rather than something specialist would be great from my point of view. You know, particularly, you know, growing a team, taking in developers that are, you know, graduates and actually having them have some understanding of how this stuff works right from the go. This quote I found, this is like 1978, but it feels like there's always been discussion about how programming languages can support different architectures. I think it feels like JavaScript has gone through lots of change, a kind of more change. I mean, maybe JavaScript doesn't have the same kind of legacy of, you know, big applications that the Java side needs to support. So it's been, you know, it's done a lot more around reinventing itself. I don't know. I think just one other point with JavaScript, I think it's this thing about having asynchronous type, you know, where you're working with a distributed system and you're actually waiting for data to come back. I mean, maybe it's better suited to that for those reasons too. Because they're not easy. Some of these problems that we've worked through, I know some of them have taken a long time to resolve, particularly the issues around concurrency across distributed type systems. So just to wrap up, sports betting, it's I guess because it's partly because it's about sport, it's good fun. There's always lots of challenges. It's an interesting industry to be in. In memory computing has really, we couldn't have done what we're doing without it. So it's a really integral piece of our tech stack. It's working well, but I'm you know, keen to hear the presentations over the next 2 days, because I'm always looking for new ideas and interested to see where this industry is going. So thank you, and thank you to the organisers as well. It's a pleasure to be
My way through the darkness.
Thank you.
hard. I can't tell where the journey